How to use AI to know the probability of a large-cap stock finishing the market day up after starting up in the first hour of trading. Using AI to determine the probability of a large-cap stock finishing the day up after starting up in the first hour of trading involves leveraging historical data, statistical modeling, and machine learning techniques. Here's how you can approach this. Keycap 1 Step 1. Collect historical data. To build an AI model, you'll need detailed historical stock data. Data required. Intraday price data, 1-minute or 5-minute intervals. Open, high, low, close, OHLC, data for each trading day. Volume data, volume traded during the first hour and throughout the day. Market conditions include broader indices like S&P 500, Nasdaq, and sector performance. Sources for data. Yahoo Finance API, free, limited historical data. Vantage API, free/paid, offers intraday OHLC data. Polygon.io, Quandl, or Bloomberg, paid, comprehensive datasets. Example data points. Opening price. Price change in the first hour, percent change from open. Closing price. Daily high and low. Sector performance. Broader market movement. Keycap 2 Step 2, feature engineering. Extract meaningful features from the raw data to improve AI model accuracy. Potential features. First hour performance. Percentage change in price during the first hour. Volume ratio. First hour volume compared to average daily volume. Volatility. High-low range during the first hour as a percentage of the open. Relative strength index. RSI. Overbought/oversold conditions during the first hour. Moving averages. 10-day and 50-day moving averages to identify trends. Sector correlation. Performance of the stock sector during the day. Feature labels. Label each day as 1 up if the stock closes higher than the open and 0 down otherwise. Keycap 3 Step 3. Choose an AI model. Several machine learning models can predict probabilities based on historical patterns. Options. Logistic regression. Ideal for binary classification, up versus down. Provides a probability score. Random forest classifier. Handles complex patterns and nonlinear relationships. Gradient boosting models, XGBoost, Light GBM, often outperform traditional models in structured data. Neural networks. Use for more complex relationships if you have sufficient data. Bayesian models. For probabilistic predictions incorporating prior knowledge. Keycap 4 Step 4. Train and test the model. Use historical data to train the model, ensuring robust evaluation. Steps. Split the data. Train 70%. Validation 15%. Test 15%. Train the model. Use features like first hour performance, volume, and sector movement. Include hyperparameter tuning for optimal results, e.g., grid search CV and Python. Test the model. Evaluate using metrics like accuracy, precision, recall, and AUCROC. Keycap 5 Step 5. Calculate the probability. The model outputs a probability score for the stock closing higher. Example workflow. A stock opens at $100. After the first hour, it trades at $103, up 3%. Input features, 3% increase, first hour volume, market trends, into the trained model. The model predicts a 70% probability the stock will close higher. Keycap 6 Step 6. Automate predictions with real-time data. Use a pipeline for real-time predictions. Steps. Fetch real-time data. Use APIs like Vantage or Polygon.io to get first-hour prices and volume. Pre-process data. Clean and transform the data into model-ready features. Predict. Input real-time data into the trained model for daily probability predictions. Output. Display probabilities in a dashboard, e.g., Streamlit, Flask. Keycap 7 Example code implementation. Here's a simplified example in Python using a random forest classifier. Python. Copy code. Import pandas as PD. From sklearned. Ensemble import random forest classifier. From sklearned.model_selection import train_test_split. From sklearned metrics import accuracy_score. Hashtag load your historical stock data. Data equals PD read underscore CSV, historical underscore stock underscore data, CSV. Hashtag feature engineering. Data, first hour change, equals data, first hour close, data open, slash data, open, asterisk 100. Data, daily change, equals data, close, data open, slash data, open, asterisk 100. Data, label, equals data, daily change, 0, the type, int number 1 for up, 0 for down. Hashtag define features and labels. X equals data, first hour change, volume, sector performance. Y equals data, label. Hashtag train slash test split. X underscore train, X underscore test, Y underscore train, Y underscore test equals train underscore test underscore split. X, Y, test underscore size equals 0.2, random underscore state equals 42. Hashtag train a random forest model. Model equals random forest classifier. Modeled fit, X underscore train, Y underscore train. Hashtag test the model. Y underscore pred equals model.predict, X underscore test. Accuracy equals accuracy underscore score, Y underscore test, Y underscore pred. Print, F, model accuracy. Accuracy. Hashtag predict probability for a new day. New underscore day equals 3.0, 100,000, 1.5. Hashtag first hour change, volume, sector performance. Probability equals model.predict underscore proba, new underscore day, 0, 1. Hashtag probability of closing up. Print, F, probability of closing up, a probability, 0.2%. Keycap 8, enhance the model with advanced techniques. Add sentiment analysis. Use social media, news sentiment, or earnings reports to add predictive features. Feature importance. Use tools like SHAP to interpret which features impact predictions. Hyperparameter tuning. Optimize the model using grid search CV or Bayesian optimization. Keycap 9 risks and limitations. Overfitting. Avoid overfitting to historical data by regularizing models. Market changes. Models may underperform in volatile or unprecedented conditions. Real-time data latency. Ensure API latency doesn't delay predictions. 10. Deploying the solution. Use Streamlit or Flask for a user-friendly dashboard. Deploy the model on AWS Lambda or Google Cloud AI for scalability. Set up alerts to notify you when probabilities exceed a threshold. By implementing this AI-based probability prediction, you can make data-driven decisions and optimize your trading strategy for large-cap stocks. Let me know if you'd like further help with specific parts of the process.